What we're going to do now is to explore some possible errors that we may encounter during explicit typecasting. So we might encounter some possible errors while we're doing explicit typecasting, which we did in typecasting example 2. Let's create another file and demonstrate that. So I'm going to copy this code and bring it up here and paste it here. Then I'm going to save this file as typecasting example 3.java. Here we go. So if you can recall, in order for us to be able to convert a short, which is a larger data type than a byte, converting a short into a byte, we needed to do explicit typecasting by specifying the data type that we are typecasting the variable into. So assuming we were trying to store the number 256 in a short, which of course you can see a short has a range of minus 32,768 and a maximum value of 32,767. So that's the range of a short. So assuming we're trying to convert a number within that range of a short, which in this case is the 256, we are trying to store that and typecast that into a byte. You can see the range for a byte is minus 128 to 127 inclusive, and 256 is well above that range. So what do you think is going to happen? Is it going to have an error? Are we going to have a compilation error? Or is it going to run properly? So let's check it out. The only way is for us to try compiling it. So we're going to clear the screen and then we are going to try to compile typecasting example 3.java, and you can see that it compiles successfully, which is quite surprising. But if we try to run the program, typecasting example 3, what do we get? We get 0. So why are we having 0, whereas we were storing the number 256 in the variable a, and we try to force the variable a, the value of the variable a, via explicit typecasting into the variable b. So at least we should expect to get 256. We're having 0. Alright, so let's take a look at this. How about we store 300 and then we try to typecast it to a byte. Alright, so let's compile the program. We compiled and we run it. You can see now we're having 44. So that's strange, right? So there is some stuff going on behind the scenes, and I'd like us to take a look at that. So I'm going to bring up the paint application and do some more illustrations again. So I'm going to select this pencil brush, and like I said before, we had a register of 16 bits, right? So I'm going to draw a box to demonstrate the register of 16 bits. So here we go. Alright, so let's start with the fact that we had 256. Okay, that 256 as the value of the variable a, and then when we tried to execute it, we had 0 as the value of the variable b, whereas we passed in the value of the variable a into b, and then we are having the result of 0. So let's see what caused it to become 0. Alright, of course we have to do the binary division over again. So 256 divided by 2, what we're gonna get. So this will give us so this is gonna give us 128, which we'll write it here, and we didn't have any remainder, so we'll say remainder 0. So 128 divided by 2 is gonna give us 64. And then we didn't have any remainder, so we'll state that we have a remainder 0. 64 divided by 2 is going to give us 32. Remainder 0. 32 divided by 2 is going to give us 16. Remainder 0. 16 divided by 2 is going to give us 8. Remainder 0. 8 divided by 2 is going to give us 4. remainder 0. 4 divided by 2 is going to give us 2, remainder 0. 2 divided by 2 is going to give us 1, remainder 0. And finally 1 divided by 2, it's not possible, so we're going to have 0, remainder 1. Alright, so we're going to count the number over in this way, as we usually do in the simple binary division. And then we can write it out here that the number 256 in base 10 equals 1 0 0 0 0 0 0 0 0. Right, 8 zeros. However, when we are storing it in the registrar, the binary registrar, we're gonna pick this number over here, put this here, pick this other number over here, put it here. This one goes here, and all those numbers are zeros, so they'll all go in the respective boxes. And then this other number 1 will go in here, and since we're not going to have any other numbers, so we'll fill the blank boxes with zeros. So this is just simply how the computer stores information in binary form. 0 meaning no current, 1 means an on current switch or current going in. So if someone now tells you to squeeze this using explicit typecasting like we did, you know, the number 256 stored in a short variable A, and we are now trying to force it into the byte B, and as you can see, byte is an 8-bit sign to complement integer. So and you can see that 127 is below the range or the number that we had in the short. So what's going to happen? Let's go back to the illustration. So you can see over here that it's gonna go out badly. So so this is a short. Okay, let's register here. We're gonna create another register for a byte. Okay, so this is a byte over here. So what the computer is simply going to do is that it's going to take the first 8 digits and place them accordingly. So we have 0 there, we have 0 here, 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 we have 0 here. So since we had already given it explicit typecasting, which is kind of like a go ahead, that okay, avoid all those possible loss of data and then store what you have in here. So what's going to happen is that the computer is going to take the first 8 bits and then store it here, and then ignore the other 8 bits. So the whole of this stuff will just simply be ignored. Right, the whole of this will be ignored, including the one here. So so what are we going to have here? You can see it's all zeros, and all the zeros is 0. So you can see the reason why we had 0 over here, right? So that is it. Let me explain the 44. You can see in the previous example again, we had 300 and then we had 44. So what could have caused this to print an output of 44? So we need to check it out and see what could have caused it. Again, I'm going to bring out the Paint Java application to demonstrate that. So we are having 300 as the initial value, and we're going to divide it by 2 using the binary division. So 300 divided by 2 is going to give us 150 with no remainder. 150 divided by 2 is going to give us 75 with no remainder. 75 divided by 2, so that's going to be 37, and there's going to be a remainder in 75 divided by 2, so 37 remainder 1, and 87 divided by 2 is going to give us 18 remainder 1. These are odd numbers, so we can't divide them without a remainder. And 18 divided by 2 is going to give us 9 remainder 0, and then 9 divided by 2 is going to give us 4 remainder 1. 4 divided by 2 is going to give us 2 remainder 0. 2 divided by 2 is going to give us 1 remainder 0, and 1 divided by 2 is not possible, so we're going to have 0 remainder 1. So if we read this up to the top, what we're going to have is 300 and base 10 equals 1 0 0 1 0 1 0 0 1 0, then 1 1 0 0 1 1 0 0 base 2. Okay, so to fix this in a 16 bit data type, we can have a 16-bit register of a short. Let's divide this into 16 bits. We have 16 boxes there. This one goes in here. This one goes in here. I'm gonna have 1 1 0 1, so 0 1 0. Okay, so this last one will go over here, and the computer will fill the remaining bits with 0. So assuming we try to convert this to an 8-bit data type, we're going to have a box of 8 bits. So we have a box of 8 bits over here, and since we are doing explicit typecasting, the computer is going to do away with the second level of 8 bits and focus on the first level of 8 bits. So what we're simply going to have in the new box is 0 here, 0 here, 1 1 0 1 0 0. So if you can convert this to decimal number, then hopefully we're sure to get 44. So let's see how we can convert that. Well, I would like to use my calculator and demonstrate to you how we can convert this binary number into a decimal number. So we'll clear this and then go over to the programmer calculator, and here we can put a binary number which is 0 0 1 0 1 1 0 0, and then convert it to a decimal number, and you can see why we had 44. All right, so that's the reason why we had 44. So typecasting, the explicit typecasting, you have to be careful when you are typecasting larger numbers, like from a short into a byte. You have to be careful that you do not exceed whatever values that was supposed to be stored in the data type that you are typecasting to. You have to be careful you don't lose precision of data. So that's it with explicit typecasting and the errors that may be associated with it. I hope you found this informative, and thanks for watching. Don't forget to subscribe on our website, and I'll see you on the next video.